Hello friends, welcome to my channel. So in this video series, we will be talk about the generative AI, and it's a kind of crash course. So we will learn the basics of the generative AI. What is actually the generative AI? How it works? What is the core idea? What is the core unit behind the generative AI? And yes, as we know, this is the world of AI. So welcome to the world of AI. Let's start this video series and let's get a basic and good understanding of generative AI. And obviously, the knowledge without action is useless. ये मैं हमेशा बोलता हूँ. So obviously, after getting this idea and theory about the generative AI, we will do the practical hands-on and we'll build a small language model live in this video series. And also we'll be talk about how to build and train an LLMs. So let's start the journey. So first thing, so what we will get from this course and what is the motive of this course and what is the outcome. So obviously we should know that what we will be going to learn and what we will be going to get. So basically the purpose of this course is to give the basics understanding of the generative AI to the course audience and the practical hands-on experience to building SLMs, that is a small language model. And we will get a basic to advanced understanding of the entire LLMs and how we can build a LLM from scratch. So we will see and learn the step-by-step journey of making these things from the step-by-step the approaches and the unit we have to take. And after that, we all know that there is a very versatile usage of generative AI models nowadays. So we are using like this chat GPT, we are using other models. We have like Anthropic, ChatGPT, we have Gemini. So these are some common LLMs we use day to day. But nowadays LLMs has a very versatile capacity and capability to generate text, to generate pictures, even to make the mod like videos, and also like the code. The basic hot popular topic nowadays is that these LLMs are like writing the code, and with this we have so much hype and discussion in the market that jobs will be lost, and how they are impacting on like various use cases that AI is automating nowadays. So that is a very wide topic, so we will discuss on this further also. But for this video series we will focus on the basics of LLMs and how we can like make, build and train them, and what are the different use cases of them. And after that, the building blocks behind the generative AI, that is the neural network. So I will say this is the basic, very basic unit of, you can say, a deep learning. So we will learn like what are the types of neural network that helps build this deep learning, and then deep learning help us to make build these LLMs. And afterward, obviously, the benefits and challenges with generative AI. Obviously, everything has a pros and cons, so we will discuss that thing in detail also. So now, like, what is generative AI? So as we all know, basically, we day to day uses these things and this technology. So AI that creates new content. So it can generate like text to text. It can generate text to image. It can generate text to video. It can generate code. So various sort of combination we have. So the AI that generates new content, basically we can say, generate text, images, code, learn pattern from large data sets, produces human-like responses. So initially we all have experiences that we do chat and communication with these LLMs, and we think like a real human is like talking with us. So that kind of sentiments and context understanding LLMs have. So they give answer like that only. Example is ChatGPT, generative pre-trained model, and this mid-journey are few example of these generative AI models. Now, what is the difference between ML and Gen AI? So, for beginners and like the persons who are not like belongs to a direct tech, so this understanding is very critical to know. See, ML is the base, And on the top of ML, we have built the various things as the picture shows. So I have taken pictures from internet, thanks to the internet, and the pictures from where I have taken these pictures to get make it more interactive and understanding for all of us. So as we can see in the picture, so we have a generative AI, and on top of it we have a deep learning, and on the top of deep learning we have machine learning, and the top of machine learning we have a AI. So AI is, you can say, a superset, and these things are subset of the AI. So artificial intelligence is a very wide domain, a very wide area we have, and under these we have machine learning things, machine learning models. There are various machine learning algorithms we have in place, so that we will also learn in a separate video series course. So these ML model build the deep learning things, and these deep learning things made this generative AI. So there is a proper bifurcation and difference between the two. So we should not get confused with these two terms. So as it says, the traditional ML predicts outcomes. So we have linear regression models, we have decision tree algorithms, we have KNN, we have clustering classification things. So those are called as ML models or ML algorithms or a machine learning stuff. And so this is taking a proper decision or outcome. But generative AI generates the content, the matter on the basis of the input given. So this is the difference. And ML focuses on like classification, it gives some decision making, and generative AI produces new text and images or videos content basically. The very basic example, we have a spam filter versus chat GPT. So we have this spam bifurcation in our mailbox also, in our Gmail also. So that Gmail read and scans the content, and on the basis of that it decides whether this is a spam or a normal email. So this is a decision making. And chat GPT, we give prompt, it give answer to us. This is generative. And afterward, we should understand, because this is very basic thing to know with, so that we can do the training of our SLMs and LLMs later. So on a very broad level, so we have a two types of data, that is supervised and unsupervised. So supervised data, basically data with labels. So data that is having information. For example, if we are doing some kind of linear regression prediction, let's say we have some sort of input data. Let's say I am predicting the house prices. So on the basis of that, I have certain set of training input data that tell me like this is the house area, this is the house price, this is the conditions. So we have some sort of input thing with some labeled. उनके ऊपर कुछ लिखा होगा कि ये फैक्ट, ये पर्टिकुलर डेटा इस फीचर को बिलोंग करता है, इसका ये नाम है. So that is supervised data, and with that we do supervised learning. So learns input and output mapping. So used for prediction and classification, the supervised one. And unsupervised, no label data, finds hidden pattern and clustering. As the diagram also showing, supervised learning, labeled data, unsupervised learning, unlabeled data, and hybrid model that includes supervised learning. So it's labeled plus unlabeled both. But in LLMs, this is widely an unsupervised learning approach. So, as we all know and listen, that we use the basically the internet data, a huge raw data to train the LLMs. So those are unsupervised learning. So those are unsupervised, unlabeled data. We have not defining that this particular sentence is that input feature belongs to that property of the model we are going to build. So when we will do this practical example, we'll take an entire book and train an SLM. So there is no labeled on that. So it is a purely unsupervised learning in LLMs. So what is training data in terms of LLMs? So as I just said, so massive text data set, books, articles, websites, billions of sentences, learns language pattern and understand context. So this is the step of training of an LLM. So this much of huge data has been used to train the LLMs. जितने भी हम LLMs मार्केट में भी हम देख रहे हैं, यूज कर रहे हैं, foundationally these are built on this much of data. So yes, and after making this foundation model, we can make them a domain specific models also, with the help of RAG approach or with the help of model fine tuning. There are many ways that we will also discuss in detail. Now, the core is the prediction of the next word. So the prediction of the next word basically is the core of your this LLM thing or SLM thing. So let's understand this. So, what you think? So, what usually these Chat GPT and other LLMs does? So you give them a prompt, they give you answer. So the basic unit behind this, basically they predict the next word only. They do the prediction word by word. Even when the training happens, it happens in the same way. We give them a sentence, and they, with the help of that sentence, they will predict what is the next word going to come in that particular line. So in that way, they are also giving you the answer in the response of your prompt in prompts. So, basically, the predict next probable word uses previous context. So this context and attention mechanism is a very critical thing to understand that we will also see in further videos. So obviously the probability involved. So it will just calculate keyword should be the next word. So yeah, maybe it can predict. So some, let's say, n number of words should come next. So on those n number of words, it will map the scores, and scores will then convert it into a probability. And on the basis of highest probability, it will put in that word, because this is a computer. Matlab, this is not a human. So everything will happens in terms of numbers. So those number approach we will also see in upcoming slides. So like sky is, so sky is blue. So it will predict blue. It will predict the probability of this particular word blue, and this particular word blue will get a highest probability, then it will return that sky is blue. So this is the idea behind the working of these models. So this is the core idea of LLM, basically the prediction of the next word. Now, the neural networks, the base of the generative AI of, or I can say the base of the deep learning. So basically, the idea of neural network is inspired by the human brain. So we in our science subject in the biology, we have learned that we have a synapses, we have node in our brains, we have neurons that connected to each other, communicate with each other. So that similar kind of idea behind this neural networks. So this is a very high and broad level diagram we are seeing here. Again, thanks to the internet and the website from where I get these pictures to make it more interactive. So this is the input layer, and this is the output layer, and this is the hidden layer. So initially, when uh, I started learning these neural network, I was always fascinating key. What is this input layer? What is this output layer? What is this hidden layer? What is actually inside it? ये होता क्या exactly? So, so these layers are nothing but a kind of mathematical functions on each this circle. So we have this input layer. We will send this input data, and as you are seeing in the PPT, this each circle is connected with each and every circle of the next layer. So basically, each this circle is a kind of mathematical thing inside it, and these lines are basically passing the data, and we have some sort of weights on it. So behind the scene, a mathematical calculation is happening, and the hidden layers we can configure while making these neural networks. So all these things are configurable, but the high level idea is that only, like the picture we are seeing. So input layer, output layer, and hidden layers. Now, what are the neural networks? Actually, the real functional unit behind the scene. As I just said, so mathematical function approximator, these are input transform to output, weights update during training, learn complex relationship, and foundation of deep learning. So this is the entire idea behind this. So we have different kind of neural networks. So initially we have simple feed forward neural network. So input comes, process, and output. And processing is basically a mathematical equation, a mathematical function is happening behind the scene. And it gives result, and the basis of result we decided the output. So it is a feed forward, just input, processing, and output. No memory, no remembrance of what is happened in any layer. It just come and go, first in first out types. So this is used for a very basic prediction. With this feed forward neural networks, we can't make a complex things that we have in place today. So after that, obviously we need a back propagation thing. A back propagation thing is a kind of a feedback that we are uh, uh, getting from the output. Let's say we have this input layer and an output layer. And output is not as expected. So obviously it has some error. So we will calculate this error with the help of loss functions. So the basic loss function is the basically the gradient we calculate. And after calculating gradient, we pass this information back to the network, and the weight has been adjusted again. And then again, it will flow to the outward. Then we will again calculate the difference between the expected output and the actual output. So this loop going on until unless we get a very less and minimal desired output or a very less error, we can say. So this back propagation thing comes into picture, and it help us to make the system more robust. So training algorithm calculate prediction error, propagates error backward, adjust weights, and reduce model loss. So this is a very basic understanding uh, with respect to training and checking the output and readjusting the in-between process to make output near to the expected output. Now the question arises, why we need memory? This is a very critical thing to ask, because uh, if uh, if some audience are already aware about that, so before getting this memory thing, so LLMs were not like performing well, because obviously let's say you have done some interaction with the LLM, you have done some talk to him, and again you came back and asked some same thing on that particular same topic, then it will behave uh, like उसे कुछ पता ही नहीं है. So that is the context keeping and the memory keeping make their reasoning skills more robust. So for to make that thing, to achieve that thing, this LSTM neural networks come into picture. So long short term memory neural network. So standard network forget context. So if they forget the context, they are not giving the right answers. They are not giving the proper interaction as we get nowadays. So LSTM keeps memory, stores past information, useful for sequences, helps understand sentences. So how it works? So it has different gates. It says forget gate, it has input gate, and it has output gate. So with the help of these gating mechanism, it keeps the memory. So determine which information from the past to discard, that he needs to forget, decides which information to store in the memory cell that he need to keep, and determines what next hidden state should be, which influence the future prediction. So it will output that particular information to the output, so that output can be more precise. So basically these are the functions. So we have seen that circles in the neural network. No, so in each circle we have these non-linear functions that are performing and helping to make the decisions. So these are some popular function we use, that value, sigmoid, and tangent touch function. So so think of it. If we have a linear function, so what will happen? Everything will come and pass. Obviously, if there is a linearity. So these non-linearity put in like the complexity in the in the model, and help it's to learn better. So these three function mainly we use and essential for making deep networks. Okay, now the most critical thing, what is the loss function? That is gradient. So it predicts the error. Example are cross entropy. Gradient shows direction. Using gradient descent, and goal is to minimize loss. So the very basic principle, let's say we want some expected output. We have done some input. It got processed in between the hidden layers and get the output. But the output is not as per the expected output. So how we will check this? So we will check with these help of these loss function. So loss function, ideally loss function is zero, but 100% accuracy, like it's not possible to achieve, but we uh, can like very close to our things. So uh, like nowadays we get like very much expected output from the LLMs. Obviously they do hallucinations, or sometimes they are lacking in making the context or reasoning, but still we are getting very much and great output nowadays. So this is happening with the help of these loss functions. Okay, now what are the parameters in LLMs? So we have seen this one, that this is a 2 billion parameter, this is a that million parameter LLM and SLM. So basically the parameters is equal to model weights. So these weights are the things that are actually learns the pattern, they learns the vocabulary, they understand the context, they understand the sentence, the grammar. So the number of model weights we have in our LMs are called the parameters actually. The large model have a billions of parameters, more parameter, more capacity, but higher compute cost. Obviously, when we will see the process, the actual process of training. So it is happening input, processing, output, loss function, back propagation, again weight update, then output, then again back propagation, weight update, then again output, until unless we have expected threshold of the output. So this kind of math is happening again. So obviously for that we need a so much very high computing power. We need a very high GPUs to process, and it is a very huge computing cost. Okay, now like what are embeddings? See, so we all know that computers only understand the numbers. So everything must be converted into numbers first. Then these mathematical function will process them and make some kind of decision again in numbers, and those numbers again converted into the human understandable thing that is the final output for us. So convert number words into number. Neural network use numbers represent semantic meanings. Similar words close in space use vector search, blah blah. So all these things we will be going to see in a shortly by a real Python program. I will show you. So embedding basically the numerical representation of the words in short. Now we have what is semantic search and cosine similarity. So when we will learn deep about the attention mechanism, uh, so we will do the comparison. So we can't compare like word by word, because our system can't understand the English or a high level thing. So we will convert everything into number. Then those number will get compared with the help of cosine similarity function. So we will see in the upcoming just example. So we will convert certain words into embeddings, and we will compare those embeddings with this cosine similarity, and you will see the king queen will get higher cosine similarity score, and the king and apple will get a low cosine similarity score, because obviously king in terms of context, king human, a king, apple fruit. So obviously they should not get a very high cosine similarity score. Okay, first let us see some examples. So if I go here, so I want to show this like tokenizer. So everything will be, so we will give sentence. Let's say so we are reading the Gen AI topics. See, so I have given this sentence. This is sentence for us. We are reading the Gen AI topics. So if we see below here, so this has been broken into 7 tokens. We are reading the Gen AI topics. 32 characters. 1, 2, 3, 4, 5, 6, 7 tokens. Now these 7 tokens will be converted into embeddings, and then further option will happen on these embeddings for the prediction of the next word as per the prompt we will give to the LLMs. See, this is basically the Python function. So I have used this sentence transformer from sentence transformer library and scale and matrix pairwise this cosine similarity function. So this is the all min LM L6 version 2 sentence transformer model I am using to convert these words into the embedding. See, so I have taken this king, queen, man, woman, apple. Now I am converting these words into embeddings. Print embedding shape, and these are so I'm currently printing the embedding for the king, embedding 0, that is at 0 index 0, 1, 2, 3, 4. So king is a 0th index. I am printing its embedding, and after that I am comparing the embedding. See, similarity close, cosine similarity embedding of 0, I'm comparing it with embedding of 1, that is queen. And in the line number 14, I am comparing the embedding of king with 4, that is apple. So now we will see the results. I'm just running it again for it's running. Why it is taking time? Okay. So this recording is happening, so maybe it has taken some time. See, so it has print first the embedding of, yeah, this is the output of this line, embedding dot shape, and the king जो एक word है उसकी embedding ये बनी है. Now I'm comparing the similarity of king and queen. It is a high score 0.68. If they exactly match, the score will be 1. So higher score, more similarity, more close. Lower score, less similarity, far apart. तो किंग और एप्पल में रिजल्ट जो है 0.24 है, दैट इज लेस सिमिलैरिटी, एंड किंग एंड क्वीन देयर इज अ हाई सिमिलैरिटी. So in this is a kind of a mathematical thing is happening behind the scene. Okay. uh, Now back to the slide. Okay, so basically the transformers, so it is first introduced in 2017, and attention mechanism come into picture. So this attention mechanism helps to understand the context, process sequence efficiently, and this is the foundation for modern LLMs. So it's a kind of a standalone individual topic, the transformer, and we will study it in a proper and a deep manner. And afterwards, so we have architecture of LLM. So architecture, basically the sequence. So first we will tokenize, split the text as we have just seen, and after that we will convert those tokens into embeddings that we have also seen, and then transformer layer process. So it will be again separate video topic, and we will find the attention mechanism and will predict the next word. So this is the basic flow of the LLM, and yeah, we will see this, and we will do this operation in the next video, the entire actual coding, and we will train the SLM, and then SLM like will be ready. And so why I'm taking the SLM, the reason behind, because as I just said in the previous videos, the building LLM is a very huge cost. So we will take in the SLM for this like demonstration. So it will be, we will train a very small book, and then it will be like lower hardware cost, faster inference. Inference basically the time after training, we called it as inference time. So when we will giving the prompt and getting the answer, that is called the inference time. And it can be a domain specific. Obviously, we will train a specific book, a small book, and we will obviously get answer on that book from that SLM. And obviously, this is useful enterprise tool. So let's say if you want to make a specific domain specific topic with with respect to your company, with respect to your anything, so that SLM can fulfill. So ending notes for this video. So we all know Gen AI is transforming the industries, coding, research, education in each and every domain. Gen AI is performing well, and this is called a human AI collaboration, important skill for future and learn, build, evaluate models. So this is the like a very basic thing about Gen AI, and in further video series we will do this practical to build an SLM. Thanks.